Hey y'all, in this lesson we are going to look at using linear models in order to make predictions with scatterplots. We want to be able to say I can make a prediction by using the equation of a line that closely fits a set of data. So our essential question, highlighted in yellow, is how do linear models help you make a prediction? We don't have any new vocabulary for this lesson, so we'll get right into the first example, which is using the slope to make a prediction. Michaela is a speed skater and hopes to compete in future Olympic Games. She researched the winning times of the past 50 years, and we can see in the scatter plot those times represented. If the trend in faster speed continues at the same rate, so rate slope, how can she use the information to predict what might be the time to beat in 2026? So she wants to know what is the time she should be trying to attain so that she can be the winner in the 2026 Olympics. The first thing we want to do is write an equation for the trend line. Our trend line, we can see represented here, we can find the slope as well as the y-intercept. We can see according to this graph that it looks like the winning time in 1960, so after 0 years after 1960, was 2.4 seconds, or 2.4 minutes. I see it is labeled as minutes, and so 2.4 is our y-intercept. We can also see from the information given here that a rise of down 0.2 minutes is represented by a 15-year increase in years. So we are going down, which makes sense. The slope is going down. So we have a negative slope and we have 0.2 over 15. If I put that into a calculator, I get about 0.0133. So this is our slope and we have our y-intercept. We can write our equation in slope-intercept form. So with a slope of negative 0.0133 and a y-intercept of 2.4, the equation of the trend line is y equals negative 0.0133x plus 2.4. Now we can use this equation to predict what the winning time might be in 2026. Now again, keep in mind that the trend line can give us an approximation, but it's not like if it ends up being a time different than this, that's okay. Like this isn't the it has to be this thing. So what we're going to do is figure out how many years after 1960 is 2026, and we can do that by taking 2026 and subtracting 1960, and that will give us that it is 66 years. So we're going to use 66 as x because that's the number of years after 1960. So here you can see plugging 66 in for x. On a calculator, we'll do negative 0.0133 times 66, and we get negative 0.8778 plus 2.4. When we add those two things together, again, using a calculator, we get 1.5222. So if the trend in faster times continues at the same rate, Michaela should target about 1.5222 minutes, or if we're going to round it off, 1 minute and 30 seconds. A little bit more than 1 minute and 32 seconds is what she should be aiming for in order to be the gold medalist in the 2026 Olympics. So this is how people can analyze data, make predictions, and then set a training course to try and be the fastest person in the Olympics. Now, you try. Assuming that the trend line in the graph continues, use the equation to predict the average fuel consumption in miles per gallon in 2025. Try to figure out the slope of the line, where it is starting, the y-intercept, and then make sure you figure out 2025 is how many years after 1980 to plug in and get a final answer. Pause the video, give this a try, and press play to see the answer. In this problem, the y-intercept looks to be right at that space between 12 and 18, which would be 15. The slope, going over 30 years, looks like it intersects at 24, which is 9 miles per gallon more. So we have a slope of a rise of 9 over a run of 30, which ends up being about 0.3. You can just do 9 divided by 30 on a calculator. Now we can figure out 2025 is 45 years after 1980, so we'll plug 45 into the equation. When we do this, 45 times 0.3 is 13.5, and add 15 to get 28.5. So it is predicted that the average fuel consumption for a fuel economy vehicle would be 28.5 miles per gallon. I'm sure you could look up this information and see if the average miles per gallon for fuel consumption is 28.5, since it is 2025. See if the prediction holds true. In example 2, we are going to use the scatter plot itself to make a prediction. So the scatter plot shows the relationship between the number of people at a water park and the temperature. About how many people should the owners of the park expect when the outside temperature is 90 degrees. So we can see here on the graph that we're looking at 90 degrees, and we see this red line going up to the trend line to give us an idea of how many people we should expect. So amusement parks like Valleyfair can use this type of information to help in planning their staffing so that they make sure that they have enough people and they have enough, they meet safety regulations for the number of people that are going to be at the park. So here we can find the y value for an x value of 90, since the temperature is our x value and the number of people is our y value. We simply have to look that when we go up to that trend line at 90, even though we don't have any specific 90-degree day data, we can hit that trend line at 90 and go over to see that it lines up with right about 800. So the park owner should expect about 800 people at the water park when the outside temperature is 90 degrees Fahrenheit. So now they can make accurate and safe staffing decisions based on the temperature. Let's look at another scatter plot. Here, this scatter plot is suggesting a linear relationship between temperature and the number of smoothies purchased. We see that label here, number of smoothies purchased. So as the temperature increases, more people are buying smoothies. Our questions are, what does the rate of change or slope represent in this situation? And what does the y-intercept of the line represent in this situation? Well, in this situation, the rate of change or slope is describing the number of smoothies purchased for each degree of temperature increase. Again, since our slope is how much we go up, for each unit we go over. So each unit is the temperature. So it's how many more smoothies are purchased with a 1 degree increase in temperature. The y-intercept, because a temperature of 0 degrees, is where the y-intercept happens. This represents the number of smoothies that are being sold if the temperature is 0 degrees. So people are still buying smoothies even when it's cold. So these are the things that is represented in this particular graph, knowing that the slope is the rate of change, how much the y changes for a change of 1 in x, and then that y-intercept of 0, because x is temperatures, 0 is 0 degrees. So interpreting the information from our graph to make more accurate predictions. So what is the equation that relates the temperature and the number of people to buy smoothies? Well, we have 2 points on the graph that we can use to find our slope. We have a point at 40, 32 and at 80, 56. We can see our line goes right here, 40, 32, and at 80, here it's going right through 56. So we can find that the slope ends up being 3/5, which you can see calculated in this bubble here. Then the y-intercept looks like it's going right at that halfway between 0 and 16, so right at 8. So with a slope of 3/5 and a y-intercept of 8, the equation for this line is y equals 3/5 x plus 8. In your try it, you're going to use the same scenario. And so we already have the equation. A smoothie cafe has the ingredients needed to make 50,000 smoothies. This is on a day when the high temperature is expected to reach 90 degrees. The question is, should the cafe employees expect to have enough ingredients for the day's smoothies? So we want to know, at 90 degrees, how many people or how many smoothies would we expect to sell? And then is 50,000, is that enough or is it not enough? So on a 90-degree day, you are going to figure out on a 90-degree day where x is 90, how many thousands of smoothies can they expect to sell? And then circle, is that enough or not enough? Pause the video, try this, and then press play to see the answer. So we're going to plug in 90 for x. 3/5 times 90 is 54, plus 8 is 62,000. So on a 90-degree day, the cafe can expect to sell 62,000 smoothies. In other words, 50,000 is not enough for this day. All right, let's summarize using linear models to make predictions. Remember that scatter plots and their trend lines can be used to make predictions about current or future trends. Current trends we're going to be looking at a spot that's on the graph. If we want to make predictions for future trends, we're going to need to use the equation of the line. So look for corresponding y and x values for current trends and find the equation of the trend line and the y value for a given x value to figure out future trends. Your next steps are to turn in your 7.3 notes, complete your 7.3 practice, and take your 7.3 mastery check. Good luck, and I'll see you in the next lesson.